What is an F-naught value? How does temperature affect kill time? And what does a 1 in a million chance of survival really mean? These aren't just abstract concepts. They are the mathematical language that separates a validated process from a dangerous guess. Are you ready to crack the code that guarantees a kill? Welcome to Decoding Sterilization, F0 value, D value, and SAL. This video is designed for professionals in pharmaceutical, medical device, and biotechnology industries, especially those involved in quality assurance, process validation, and manufacturing. If you're responsible for ensuring product safety and compliance with global sterilization standards, this content is crucial for you. By the end of this video, you'll gain a deeper understanding of the critical mathematical concepts that underpin effective sterilization, helping you to confidently validate processes and achieve the highest levels of sterility assurance. You'll learn what an F0 value is, how temperature changes kill time, and what a 1 in a million survival really means. F-naught, Z value, and sterility assurance level. These aren't abstract theories. They're the math that separates a validated sterilization cycle from a dangerous gamble. Let's decode the numbers that guarantee a kill. Microbial death in an autoclave isn't random. It follows first-order kinetics, meaning in each time interval, the same percentage of microbes die. To design a safe, validated process, we need to measure and prove that math. Start with the D value, the time needed to reduce a microbial population by 90% at one temperature. Now what happens if we raise the temperature? That's where the Z value comes in. It's the temperature change required to shift the D value by a factor of 10. For steam sterilization, the Z value is typically 10 degrees Celsius. So if Geobacillus styrothermophilus spores take 1 minute to reduce at 121 degrees Celsius, then at 131 degrees Celsius, they die 10 times faster. But sterilization cycles aren't steady. They heat up, plateau, and cool down. How do we measure the total lethal effect across that entire curve? That's the F0 value. F0 condenses the whole time temperature profile into a single number, the equivalent minutes at 121.1 degrees Celsius, with a Z value of 10 degrees Celsius. For example, 1 minute at 121.1 degrees Celsius equals 1 F0 minute. But 1 minute at 131.1 degrees Celsius? That equals 10 F0 minutes, 10 times more lethal. And what's the ultimate target? The sterility assurance level. Global pharmacopoeias and GMP require an SAL of 10 to the power of 6 for terminal sterilization. That's less than a 1 in a million chance of a non-sterile unit surviving. Now let's quickly test your knowledge. Question 1. If you increase the sterilization temperature by the Z value, which is 10 degrees Celsius, what happens to the D value? The correct answer is, it decreases by a factor of 10. That's the definition of the Z value. It's the temperature shift needed to reduce the D value tenfold. Question 2. What does an F0 value of 15 mean? The correct answer is, it represents the equivalent of holding the load at 121.1 degrees Celsius for 15 minutes using a Z value of 10. It condenses the entire heat exposure into one standard reference point. Question 3. A sterility assurance level of 10 to the power of 6 corresponds to what probability of a non-sterile unit? The correct answer is 1 in 1 million. That's the globally accepted sterility assurance level for terminal sterilization. Now you know the math that proves sterilization. Next, we'll shift from numbers to machines, exploring how different autoclaves protect both your product and your people. Be sure to check out our next module, Operator Safety and Autoclave Types.